Hey everybody, I hope you're doing well. And let's kind of go ahead and get started. We'll have a couple lessons like this, but you're going to have some activities that I'm going to be expecting you to do kind of on your own. So you're going to need to find some material, something to work off of. So we're going to do a little bit of astrophysics, a little bit of astronomy, and start with just some of the basics of understanding the solar system. Now, a lot of times you're going to get pictures like this, and so just some quick facts. I think what I love about astronomy is just some of the information. Like you look at the sun, 99.86% of the mass of our entire solar system is within the sun. Jupiter has maybe like 0.1%, and then everything else is spread out among all the other little planets. So we start out with the center, then we go to the inner planets, Mercury, Venus, Earth, Mars. Then we move out to the outer planets with our Jupiter, Saturn. It's Uranus is the correct pronunciation of the planet, Uranus. It doesn't help that scientists discovered that it's methane gas, which smells, so I know your students are going to have fun with that one. Then we end up with Neptune. Now, Pluto is also technically part of it as well, but that's a lot of historical reasons, and we'll actually get into it a little bit later, another lesson as to how we discovered Pluto and where is it at now. So beyond that, we have the Kuiper Belt, where a lot of comets and fun stuff like that. The Oort cloud goes out beyond that, and then anything beyond the Oort cloud is you're technically kind of leaving the solar system. So what is the following? Pause it for a little bit after this, and just think about what this could be. My very exciting magic carpet just soared under 9 palace elephants. What might that be? So pause it for a second and come up with an idea. All right, so now that you have kind of an idea what it is, but this is actually a mnemonic. You might have, we know the planets Mercury, Venus, Earth, Mars. Ceres, you may not know, Jupiter, Saturn, Uranus, Neptune, Pluto, and then Eris. And you may not know Ceres and Eris, but Ceres, Pluto, and Eris were actually the first 3 dwarf planets. So when the American Astronomical Society came up with an idea to come up with a new mnemonic for the order of the planets and the original three dwarf planets. So you might have heard, my very educated mother just served us 9 pizzas, or something of that nature. You can sing it, my very educated mother just served us 9 pizza pies. That was a mnemonic to help us remember the order of the planets. So this was actually one, I think it was by an elementary school, who used a Disney movie, which you probably can think of which one it was, as inspiration to come up with a new mnemonic. And so in case you don't know which Disney movie it is, dealing with magic carpets, soaring, and palaces, we're talking about Aladdin here, folks. Now, I don't like this picture. And if you actually look at it, this is typical of what most pictures of solar system or what our solar system looks like. You got the sun, you got all the planets right up. So why do you think I don't like this? Well, there's a couple reasons. 1, you don't have the planets all in a nice line like this. 2, they're not that close together. So if you're looking at the scale of it, so when we're talking about standards, and especially next generation science standards, one of the overall themes with it is size and scale. And this is one of the most difficult things for students to kind of comprehend. And so when we show them pictures like this, we kind of understand why. This is incredibly misleading for both size and scale of the planets. So to kind of help you out with this, I'm going to show you a couple different methods to think about size and scale. So first we have the inner planets and Pluto. So Mercury, Mars, Earth, and Venus, and Pluto. So this is kind of a rough scale of how they are. But now that we throw in the outer planets, Jupiter, Saturn, Uranus, and Neptune, we're starting to get a better ideas just on the size of how the planets compare. But now you put it into the sun, we're starting to see some bigger comparisons, and we just get an idea as to how big the sun is. But you got to remember, our sun is a star, and that there's actually one of billions of stars out there. So when we look at some of the other stars, because there's really nothing all that special, it's average size, average age, average. Sirius, Pollux, Arcturus. Earth you can't even see on the scale. Jupiter is about the size of 1 pixel here. Sun's pretty small. But there are some other larger stars out there as well. So the sun is 1 pixel in size on this picture. Sirius, Arcturus, Pollux, now you have Rigel, Aldebaran, Betelgeuse, and that is not named after the movie. But Betelgeuse is actually part of the Orion constellation. It's the right shoulder. You'll see the little red one there. That's Betelgeuse, which actually could go supernova at any point in time. And then Antares. So these are some of the other ones. Now what I want you to do is you have your worksheet. Stop the recording now, go to that assignment sheet, and I want you to watch the video that's in that link and go through, and that way you can kind of play it there, and I want you to have the actual link for it. So go through, watch the movie. When you're done, come back, we're going to do an activity, and then we're going to pick it up from there. Okay, so after you watch that, anyone know, try to take a guess as to what the movie was where that sound came from? It was actually an old Disney movie from the 1980s called The Black Hole. But, so now that you walk through it, and hopefully that puts some things into more perspective dealing with sizes, what we haven't talked about yet is too much is about the scale. We can get a better idea as to how the planets are in size, but what about the scale? So what I'm going to have you do is I'm going to have you, at the end of this video, we're going to stop it here, but we're going to pause it here, and then I'm going to want you to think about how big is the moon and where is it at? So I have here, and we would have done this in class, but it's a little globe of the Earth. It's 1 inch in diameter. So I want you to get something, get a piece of paper, wrap it up if you want to get some modeling clay if you have some, or just draw on a piece of paper, draw a circle that's 1 inch in size. What I want you to do is, without doing any research, without any guessing, I want you to figure out how big is the moon and where would it be located. So just think on your own, don't do any work, don't do any research rather, but just either draw it on the picture, think about how big is the moon and where is it at. So stop for a second and then come back once you have that completed. Now, if we were in class, I would actually have you go around and looking at different groups, different ones, and just seeing like how big did they make their moon and how far away did they put their moon. Now what I want you to do, now I want you to figure this out for real. I actually want you to do some research on this. So what you're going to do is I'm going to give you a little bit more instruction than what I normally would do in class because you're not there to ask me questions, but you're going to be setting up ratios. We're creating a model of the Earth, Moon, solar system. So we know that the Earth in this model is 1 inch in diameter. What I want to know is how big is the moon and where is the moon located on this scale. So you're going to be setting up a ratio between my scale, which is 1 inch, and the actual value. So you actually need to do a little bit of research now. What you need to figure out is what's the actual diameter of the Earth? What's the actual distance from the Earth to the moon? What's the actual diameter of the moon? And once you have those things, you know now your ratio. However big the diameter of your moon is, that's equal to 1 inch on our model. So you convert the distance from the Earth to the moon into a scale in inches. You convert the size of the moon on a scale to inches. So do that, and let's come back and talk. So now that you've paused it and gone through, hopefully you have the scale set up. And again, if you ever have questions, you can always email me. But what you should have found out was that the moon is about 1/4 the size. So if I take my modeling clay and I build something, and I can use my modeling clay, 1/4 the size, and it's going to be about 30 inches away. So this is about 30 inches. I can't get back any further. That's how far your moon is going to be away from the Earth. A 1/4 inch diameter object, whatever you made, that's about 30 inches away from the Earth. So that kind of gives you an idea as to the size and scale. Now what you can do, if we start thinking about using this scale, we can actually make a model of all the planets in the solar system. The Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. So imagine that our Sun's in the center. We know that the Earth is 1 inch in size. Where are some of these other ones? So I'm going to let you pick one and figure out what's the size of it going to be. So choose any of the planets, or you can even use the Sun. What's the object of comparison? Like, what would it actually look like? And then how far away is it from the Sun? So I want you to pick one or two, follow the directions actually in the assessment sheet, and fill it out. So pause it, then come back. So this kind of gives you an idea as to what it all looks like. Because like I said, I didn't want you to do all of them. But, you know, the Earth is 1 inch in size. You know, some of them, like Jupiter, is almost a foot in diameter. And it's a mile away from the sun. Which is kind of crazy to think about. It's a mile away. And Pluto is 7 miles away on this scale. So hopefully that puts the size of the solar system a little bit better into comparison. Now, there's a video of that activity. So that video is in your link in the assessment sheet. So I want you to go watch that video and answer the reflection question, and then we're going to come back and you're going to do the next topic.